All right, so I want to talk about some functions, and I want you to get in the habit of being able to look at functions a little bit and think about what they're going to be before we even graph them. And it takes a little bit of practice, but I think we can do this. So if I have a function like cosine of x, we feel pretty good about what that's going to look like. Say yes. Yeah, all right. That makes me feel good. And just as a reminder, cosine of x, it starts at its maximum and oscillates back and forth. Okay? And cosine of x, the midline's the x-axis. Okay? So far, so good? What if we took a look at something like cosine of x squared? How's that going to change things? Is it going to change things? Is it going to be the same? And this is this is a good courage for the deed sort of conversation. Monty, you want to try some conversation out? And you have to be willing to be wrong. So we'll collect some data, then we'll look at it, and then we'll see what was right. Okay? All right, so the x values, Monty's saying, the x values are getting bigger. All right? That's going to do something. I agree. All right? Danny, Travis, Peter? Is that like a horizontal stretch? All right, so there's a thought, is it a horizontal stretch? So let's see. X gets bigger. And I'm going to say it gets bigger faster, right? Horizontal stretch. All right, Travis? Oh, all right. Peter?
Maybe like, goes diagonal, like the whole thing is like shifted like this.
Okay, so Peter's idea is maybe like it opens more upward, so is there like a diagonal? Corinne? Did you have your hand up, didn't you? Oh, you sure? All right. I thought someone did. Elizabeth, did you? Max, did you? Did someone there did?
I did, but then I was like...
all right, fine. Mo? Oh, I thought that was it. All right,
No,
fine.
sorry.
Anyone else? Come on, we're just having fun. Sam and then Monty again.
I'm going to say compression.
All right. So is there a compression? Monty?
Yeah, I was going to say this too.
All right. Travis?
All right, follow me here. It starts to spiral.
Oh, now you're just making stuff up. All right. So here's one thing I'd like to point out. Whenever you see the cosine of something, the cosine or sine of something will always oscillate between two values. Now, since the coefficient is 1 in front, cosine is going to oscillate between what?
-1 and
Yeah, and I'm asking you specifically, what are the min and max if the -1 and 1? So the cosine of something is going to oscillate between -1 and 1. So I have a feeling that it's going to oscillate between -1 and 1. Let's take a look. You can get your calculator out. And if we look at cosine of x squared, and we take a look at the graph,
that's crazy.
That is a little crazy.
Weird.
It looks to me like around the origin, it actually sort of looks a little like cosine function, right?
Mm-hmm.
And as we move out, it looks like the cosine function, but what happens the further we get out? It compresses more. All right, so Corinne says, look, the further out we go, the more it compresses. And this actually ties into exactly what Monty was saying. His first comment was the x values get bigger. And since x is getting big fast, that means it's going to compress faster and faster and faster. If it was just cosine x, it would just stay the same. It wouldn't compress. It would just be a nice oscillation back and forth. But since it's x squared, and x is going to get bigger, faster, and faster, and faster, that means the compressions are going to go faster and faster and faster. As a matter of fact, if we were to, take a look, I'm going to go maybe out to 10 for my x max. Take a look at that. Oh, my goodness. I mean, it just looks like a mess out here, right? It's oscillating back and forth so very fast. So let's see. If we go back there, x does get bigger faster. It is sort of like a horizontal stretch / compression, but it's not an equal compression or stretch. It's not like every value gets stretched or compressed. You get stretched out when you're close to the origin. You get compressed the further out you go. No diagonal, Peter, but hey, I got a function for you. If we do y equals 2x plus cosine x, what does this part of the equation look like? Two x is a line with a slope of 2. We are going to add to that. Here, I'll get away from cosine for a second. I'll do sine. We're going to add to that a function, a sinusoidal function. What do sinusoidal functions do? They oscillate. That should be first thing out of your mouth. What do sinusoidal functions do? They oscillate. And sine of x is going to oscillate specifically between what and what? -1 and 1. So this function is going to look like a lot like 2x plus 1, but it's also going to look a lot like 2x minus 1. Let's take a look. Peter, this function's for you. This one goes out to a very special pre-calc student. Come on, that's funny, right? I am. I was so smitten with my own humor that I just got a little crazy. Come on, you'd listen to that, like pre-calc radio, like 24 hours a day, coming at you.
I think they should put a section on Preston's
all right, sorry. I can't. You guys are making me laugh. I want to do zoom decimal, and that didn't help at all.
Oh, God.
I know that didn't really help at all. Let's. I'm gonna try zoom standard and see if that helps. Ooh, that's a little better. And can you see this function oscillating? And I think I can probably make it oscillate more if I put a coefficient in front of sine x. So I'm going to do second insert, and I'm going to insert 3. So the function is now going to oscillate between 2x plus 3 and 2x minus 3. Is that better? You like that better?
Yes. That could be on a logo.
Hey, look at this. I'm going to draw 2x minus 3, and I'm going to draw 2x plus 3. And look, the function's bound by that, right? So, Peter, this is yours. This is the diagonal one. It's a combination of a linear and a sinusoidal function. All right. You're just getting ridiculous now. Yeah. Yeah. It is. All right. Oh, all right. You can try me.
Is this like when we did like exponential growth and decay, but of sine functions?
All right, I'm not there yet. I'm getting there. So hold on, because that's what I have up here. I have two more functions that we can sit and look at and talk about, right? Sine of e to the x and e to the x times sine x. So let's look at sine of e to the x first. What does the sine function do? It oscillates. And here, I'll put a 2 in front of the sine, just for fun. So this is going to oscillate between 2 and negative 2. Now, what does e to the x do? And I want you to think about sort of Monty's statements about the first function. What's e to the x do? How is e to the x different from just plugging an x into this? Evan? It does. And what does that do to the function when we have it as an exponent instead of just as like y equals x? What does e to the x What's that ringing a bell when I say e to the x? What are you thinking?
That test.
Exponential growth, yeah, and you're right, Evan. That was a test we had to do. Good job. Exponential growth. So again, we're thinking x is getting big, and it starts small. So x starts small and gets big fast. So let's take a look at that function. Let's see if our intuition is right. So again, it's going to oscillate. That's the first thing. It's going to oscillate between 2 and negative 2. But it's going to oscillate at a different rate. Let's see. E to the x. And I'll go to zoom decimal again, maybe. See if that works. Whoa, check that out. Holy cow. So when it starts off, does it oscillate quickly or slowly? Very slowly. But then as x gets big, it oscillates
It's like a roller coaster.
super fast. All right? So it oscillates back and forth between negative 2 and 2. Not only that, when x gets big, it oscillates faster and faster. Just out of curiosity, so this is a follow-up. Whoops. This is a follow-up to Rafi's statement. What if I put e to the negative x in here? What does that remind you of? Max, e to the negative x? Nope. Mo? Michelle?
No.
Corinne? She's not even listening to me now. That's all right. E to the negative x? Yeah. What does e to the negative x do? All right, Evan. Yeah, all right, I know, but what?
So like you start out.
I know, you're doing too much. But all I want to know is e to the negative x. What should that remind you of? Like that should remind you. No, stop. It should remind you. All right, fine. I'm sorry. You're actually right. You're telling me that x and negative x, plugging them in, gives you a flip. And that's totally right, and that's something we learned, and I apologize. I'm being very rigid because I'm thinking about one thing that I want as an answer, and you're giving me another answer that's totally right. Please accept my apology. All right.
Only if you take off that point you gave me earlier.
Nice. That was good. That was good. What am I trying to get you to say? Nope. No. Thank you, Monty. Thank you. I'm trying to get you to say, instead of exponential growth, like Rafi said, exponential decay. And
That's too easy of it.
come on. And so this one starts off decaying very rapidly, and then as x gets bigger, it decays more and more slowly, so it oscillates back and forth more and more slowly. All right, let's take a look at e to the x times sine of x. Now here I'm multiplying two things. What does sine of x do? It oscillates. Sine oscillates. What does e to the x do? Exponential what? Growth. So I have a combination of two things. I have something that's going to oscillate, but it's also going to grow exponentially, because I'm multiplying those together. Let's take a look. How's our intuition? Is it something that oscillates and grows? Let's take a look at the graph. Whoa! Whoa! All right. I think I need to I'm going to try zoom standard. I might even have to zoom out more. So let's see. Wow, look at that. Look at that. So it oscillates a little bit, and as x gets bigger, it oscillates a lot. I mean, a whole lot. Would you look at that? That's crazy.
Can we send a
It's
bubble
not
man
bad.
on it?
Okay, fine. Because Sam asked. We'll send Bubble Guy for a ride. Oh, actually, I don't know if he's going to go on it. He's actually going to trace
You
it.
have to do it again.
Yeah, I have to do it as a second one.
That's disappointing.
Sorry. Racist? Whoa! Oh, oh man! He went by really fast. I didn't even see him that. Oh my gosh! Very, very fast.
Like setting to him how well
All right.
Is it possible that roller coaster makers just put
Yes.
science functions into their...
Yes, that's what they do. Actually, a lot of physics behind roller coaster making. Okay, a lot of physics. A lot of classes in physics. That'd be good. All right, Michelle, because it's so obvious and it's such an easy answer, you wouldn't even want to say it. E to the negative x?
Oh, I don't know.
Decay, thanks. That was good. That was good. You had me for a second. So here we have... When I've been known to throw erasers and markers.
Mr. Klein whacked us with chalk.
But I'd actually have to say I haven't had a class drive me crazy in a while. So
What was the last one?
thanks.
Which was
Thank
the
you.
last one that drove you crazy?
It happens more in 9th and 10th grade. So I think I had like a geometry class about 4 years ago. And it's usually not classes so much as specific students. All right, so decay. So here I have something that's going to decay and oscillate. And this is actually, let's see, if I graph this, wow, check that out. Oh my goodness. Here comes Bubble Guy. Now, I'm actually going to take a look at a better, I can't even talk, I'm sorry. I'm going to look at a better window, and I'm going to look from the window from 0 to 10, and specifically, I'm going to look just between -1 and 1. I hope this is a good window. And here comes the Bubble Guy. And notice that he is oscillating, but, well, he's not going to oscillate between -1 and 1 because he's also decaying, and I actually thought he was going to do something a little more interesting here. Well, how wrong am I? Let me try something else. Let me try, like, from -0.4 to 0.4, see if that helps at all. I was hoping I could show you something, but... Let me, hold on. I want to see if I can get a good graph, and I bet you the book has a good one. Because I wanted to make a point for my physics students today. Let's see. Oh, all right. Whoops. Alright, this is better. Alright, so I actually just changed the period so that the period happens a little more often, and we can see Bubble Guy here. And this is actually a very interesting graph in physics. It represents something that we call damped oscillation. And damped, not damned, damped. D-A-M-P-E-D. And damping damping means that it oscillates, but the further you go out, the less it oscillates. And this is actually, if you think about like a spring or a pendulum, as it goes on, if you want to take into account air resistance and friction, this is exactly what happens. It doesn't oscillate back and forth perfectly, but when you have air resistance, it's going to slow down and stop swinging as much. So if you can think about like a pendulum swinging back and forth, or if you pull like a mass on a spring down, it'll bounce up and down, but the longer you wait, the less it goes up. Or what?
Like a ball, or like
a bouncing ball.
Time that you bounce it bounces really high.
Yeah. Now, the bouncing ball is not going to have like a midline, but it's the same idea, like it will bounce a little less each and every time. Yes?
Mathematically speaking, does that go on forever?
It does. As a matter of fact, you could zoom in closer and closer, and you could still see these small oscillations, and they would happen a little further and further apart. But, yep. All right. Have an awesome Thursday. Yes.
I usually, it's not as bad.